Good day, sixth grade. Today we are going to, or you are going to take notes on the Chapter 10 review. As with anytime we do notes on a video, you're just going to have to pause me as I'm going to go pretty fast, but luckily you, again, can hit the pause button when I'm going too fast so that you can stop the screen from moving. So here we go, a quick version of the Chapter 10 review. You should be writing the title, you should be writing the I can statement. You do not need any cheat sheets over here. And here we go. Main idea number one, classifying quadrilaterals and polygons. To get ready for this test, you are going to need to know all of those vocab words. Many of them name shapes. Some of them are dealing with the definition of polygons and irregular polygons and regular polygons, and I think diagonal is in there, and non-consecutive vertices, and all of those words. Make sure you're good with the vocab from 10.1 and 10.2. Secondly, I think it was 10.3, we did area and perimeter. Quick review, area of a rectangle is base times height. Area of a triangle, base times height divided by 2. Remember, a triangle is half the size of a rectangle, therefore that's why we divide by 2. Perimeter, add up all the sides of a shape. Down here, number 5, we have a rectangle with the congruent markers showing so that we know the top here and the bottom here of this particular two-dimensional shape are congruent, whereas the sides left and right are congruent as well. Moving on to 10.4, area and perimeter of irregular shapes. Remember, we are chunking them in order to create polygons that are much easier to calculate. That would be number 6. And then number 7 is if we have a really funky, odd, irregular shape like so. There are 3 steps we use to solve. We counted the full squares, we combined the partial squares into whole squares, and then we added them together. So we added the full squares with the partial squares that were combined to full squares to get the estimated total area of an irregular shape, such as this. 10 point, or not 10 point anything, but we talked about parallelograms at some point. I think it was 10.5, 10.6. The area of a parallelogram is the same as a rectangle. It's base times height, because a parallelogram, if chopped, if the triangular part of one end were chopped off and attached to the other side, you would have a rectangle. So base times height. Just be careful you're not calculating with the side should you be given a side length. That's parallelograms. Trapezoids we worked with in Wake Up a lot. Here's your formula. You also have the other way of calculating with 1/2 times height times parentheses base 1 plus base 2. The 2 big points to remember is if you have a trapezoid like this where it's sort of tipped up, the bases are always going to be considered the parallel. The bases are the parallel sides of the trapezoid. Then the height would be the area between the bases. So imagine this trapezoid. Typically, if we just pushed it over, it would be laying on base 2 here. But since it's upwards, the bases are still going to be the parallel sides, with again the height being between the bases. Don't know that I needed to repeat that, but I just did. Kites and rhombuses, number 6. Here's your formula. D does not stand for dimensions. D stands for diagonals. Remember, diagonals are what I'm outlining right here. They connect non-consecutive vertices. So D1 times D2 divided by 2. Be careful. First of all, we have this vertice that I'm highlighting right here is a complete total length of 15. The diagonal, I don't think I said vertice here, but I meant diagonal. The second diagonal, I only gave you one part of that. It's 4. The second part is also going to be 4 because both sides of this kite are congruent. So I just said be careful that you don't forget to add that second part in, so the total length is 8 of that diagonal. Pythagorean theorem, a squared plus b squared equals c squared. It applies only to right triangles. Your a and your b are your legs. The legs make up the right angle. The hypotenuse is c. You undo a square root. You undo a square with a square root. And there's your symbol for square root. Block 1 math should be pretty simple for you because we've been doing this pretty much all year. In algebra, the number 1 goal is to get the variable alone. How do you do that? You do it with inverse operations, or you undo operations. Addition is undone by subtraction, subtraction is undone by addition, Division is undone by multiplication, and multiplication is undone by division, as you know. And 19 is an example of a simple one-step problem in which we're getting the a alone, the variable alone, by undoing what is attached to that a, which is the positive 7, and we're undoing it by subtracting 7. Volume, capital B times H. Capital B stands for area of the base. The difference is when calculating the volume of a rectangle, the area of the base is length times width. When calculating the volume of a triangle, the area of the base is length times width divided by 2. And then obviously you still have to, on both of them, multiply by the height. This is the volume formula we need to know for prisms. Area of the base times the height. Surface area, no formula. Add up the area of all faces. So if there are 6 faces, you find the area of each of the 6 faces in a rectangular prism or a cube. In a triangular prism, same thing, you add up the area of all the faces. You just need to remember that you're finding the area of a couple of triangles in triangular prisms. Lastly, logistics, area, unit squared, volume, unit cubed. Volume is units cubed. If I tell you to give me plugins, you need to know what that means. Know where the square root button is on a calculator, which I think you all are probably pretty good at. And then the last thing I said is I will not try to trick you. I will not give you a problem in which the problem is unsolvable. A couple of times in your notes I left off some dimensions just to see if you were paying attention to the formula, but on the final test I will make sure that every problem is solvable. There will be no missing dimensions. If there are missing dimensions, you will be able to figure out what they are using either algebra or the Pythagorean theorem. Make sure you get all of these notes done and into your notes, whatever it is or however it is you take notes. If you are not a digital note taker, take a picture of it and put it into your digital Notability file or digital notebook in Notability. Have a great day.